Okay, so welcome everyone. Thank you for coming to CoverWallet. I'm Pablo Molina, I'm CTO of CoverWallet. So for those of you that doesn't know, CoverWallet is an online solution for small businesses in the US to buy and manage insurance. The shortest way to explain this is I usually use is if you have to do a transfer on a bank and then you are asked to go to the branch downstairs and you cannot do that online or with your mobile phone, you just immediately change your bank. Okay? So that is something that already happened with bank industry. We are doing the same revolution, the same transformation in the insurance industry. Okay? So in the US, there was no way to buy insurance for a small company online. You just need to call and fill out the 11 million forms to have a quote, and we made that possible. And we did that using technology, right? We usually say data, design, and technology. And since we started almost 4 years ago, we had raised an important amount of money. It's about $60 million in the US. And we are already 70 engineers. I think we are 8 engineers. Most of them here in Madrid, in this office that we just got in February, and some others that are just visiting. They are here around in Valencia. So we have 2 locations. And yeah, since we got into this office, one of the goals was to host these kind of events, and then for us to hear from the experts what they do with their technology and have an exposure as well, so that everyone would know about us and also do kind of networking. Okay, so this is live right now, streaming. Thank you, Alberto, for that, and we are recording this. Thank you for the Cloud Native Meetup to host this CoverWallet. There are some pizzas and drinks that we just give around to everyone later. Okay, so thank you.
Okay, thank you. Yeah, it's really awesome to be here. It's my first time in Madrid. Got to do a little bit of sightseeing. But I'm not here today to talk to you about my sightseeing. I'm here today to talk to you about a new project called Kudo. The subtitle for this is Kubernetes Operators the Easy Way. And over the next 30 minutes, I'll be walking through exactly what that entails. I've got quite a lot to fit in. Fortunately for me, I talk fast. That's unfortunate for you, because I assume most of you aren't native English speakers. If I'm speaking too quickly or if anything's unclear, then please just stop me, ask a question, and I'll do my best to answer. So in terms of what I'm going to cover, we'll talk a bit about stateful versus stateless applications and what that actually means. And then I'll go on to talk a bit about some of the facilities that Kubernetes offers to actually manage those, the problematic of the two being stateful workloads. So we'll talk a bit about stateful sets, and then that will lead on to Kubernetes operators, so I'll talk a bit about those. And then that will segue quite nicely into Kudo itself, where Kudo fits into the picture. So I'll set the background as to where Kudo came from, introduce some of the concepts that Kudo brings to the table. Fingers crossed for a live demo. This is not only live demos fraught with peril at the best of times. I'm doing a live demo whilst joined on a Google Hangouts. I'm going to spin up a local Kubernetes cluster and deploy an operator, then deploy Zookeeper and Kafka. So my poor MacBook Pro is definitely going to be under pressure to deliver. Hopefully it's got enough horsepower. And then, yeah, we'll talk about the future of Kudo and how you might get involved, because it's a pretty cool project. So a bit about myself, first of all, as is obligatory for these sorts of things. I'm the community engineering lead at Mesosphere. I've been building stuff with open source software for about 20 years, stuff largely being cloud platforms of different shapes and sizes. I've worked for companies large and small, and I've worn many different hats in that time, ops, dev, and then pretty much everything in between. However, the point I wanted to make is that I'm relatively new to Kubernetes, right? I'm definitely not a Kubernetes expert. I'm not new to ops. I've been running applications on different platforms in production for a variety of different companies for a long time. But the reason why I make that point is twofold. Number one is Kudo is perfect for someone like myself. Someone that wants to run an application on a platform like Kubernetes, then you're running it in production. There's a business expectation that it'll be a mature service and that it's going to be it's going to be quite stable with all the belt and braces stuff that you'd want in data operations. And Kudo is perfect for that kind of thing. And the other reason why I mention it is because if you ask me any really hardcore questions about Kubernetes, I won't be able to answer. I'm a bit like this dog here that's flying a helicopter. Helicopter's coming upside down. I have no idea what I'm doing. That's largely true for how I work in front of a computer at the best of times. So doubly so when it comes to Kubernetes. Okay, so getting started, I'm going to talk a bit about stateless applications first of all, because this is a nice gentle introduction. And stateless applications, they're the simplest kind of service that you can deploy in your cluster. I'm sure this is nothing new to anyone that's here. These applications are ephemeral. They're basically binary, either they're on or they're off, and they don't need to persist any state anyway. They don't need to save any data to disk. They don't need to save any data across a network. They don't need to share any state information between themselves. They just exist in isolation. And you get, for an example session might be you get a client request that comes in. Typically, you stick a load balancer in front of this stuff. The load balancer takes care of redirecting your client request to one of these service backends. It does its thing. Session's finished. And then every time that client comes back along again, it's as if it's a brand new session. There's nothing that's persisted between the two. These are relatively straightforward. Because they're ephemeral and because they're sort of binary, like on or off, they're very easy to scale up and scale down. We can just add more of them. We can just bring them up. We can shut them down again. Very, very straightforward. And really, container orchestration environments like Kubernetes are perfect for this kind of thing, where you sort of define in a declarative fashion what your infrastructure wants, what you want it to look like, and it takes care of reconciling the rest and making sure that it's running the right number of services for your environment. And it's this sort of thing as well that's this is a pretty fundamental tenet of the microservices application architecture, or the microservices pattern. The idea that you've got all these services in production, they're deployed as services with a very defined logical service boundary, and then we can scale up and scale down in interdependent sections of that application or of that infrastructure with their own set of considerations. So these are all very straightforward, easy to scale up and easy to scale down. Also super easy to upgrade. So if you want to run a new version, you can do stuff like blue-green deployments. Again, a load balancer with a bit of smarts can take care of redirecting a certain percentage of traffic towards one of our backends. And then once we're happy that service version 2 is performing as we'd expect, we can simply roll forward. And then the same is true in reverse as well. We can easily roll backwards. So stateless applications, super easy. And if all applications are stateless, the world of application deployment and our lives in general would be really, really simple. I mean, to be honest, in our industry, a lot of the time you kind of believe that that's the case. The way a lot of people talk about this sort of thing, the way a lot of people talk about container orchestration environments, you could believe that stateless applications are the default, which they aren't. There is another class of applications, which are stateful applications. And you and I know that someone somewhere is going to want to come along and run something like WordPress on your lovely Kubernetes environment, which means that you've got a MySQL database somewhere, which means you've got to persist data, and then you need to start thinking about what it means to run that service that persists data, as a service with a degree of scalability, with a degree of stability if you lose an instance, and all of a sudden things get much more complicated. So I mean, distributed stateful systems, this is a whole complicated area of computer science unto itself. These applications have a very specific set of lifecycle states that require a set of very specific operational considerations when it comes to handling things like upgrades, when it comes to things like restarts, or when it comes to things like backups. And because this class of applications, there's such a variety of implementations, all of which have different trade-offs. So again, consistency versus availability versus partitioning. Basically what this means is that you can't treat stateful applications the same, right? The way in which you treat a Galera cluster is very different to how you treat a HFS deployment, which is very different from Cassandra, very different from Kafka, and so on. They're all very different. So they're very much, these special snowflakes that muddy up your otherwise beautiful container orchestration environments. So although Kubernetes itself, the background of Kubernetes was really that it comes from this idea of running stateless workloads, and it had very much a focus on running stateless workloads. One of the fundamental features of Kubernetes is the idea that you can move pods around, or the scheduler can move pods around arbitrarily between agents, and that's definitely something that stateful applications do not like. They don't like the networking to change, they don't like the storage to go away. That sort of stuff is absolutely a no-no. Fortunately, there's been a few features added to Kubernetes over the years in order to try and handle some of the complexities with stateful applications. It has this concept of stateful sets. Stateful sets are designed to address exactly those things that I'm talking about. So you define a stateful set, and with it you provide, or with it you can provide a stable and unique set of network identifiers. You can provide stable and persistent storage for your application, and it gives you some control over things like deployment and scaling and deletion and termination, that sort of stuff. Which is by and large great, but the problem is that Kubernetes itself by default has no visibility into what's going on in the pods themselves. This is a very generic approach. It's kind of coarse-grained, and it's sort of one size fits all. And as I mentioned before, these stateful applications tend to be something of a snowflake. So the stuff that you might configure via a stateful set doesn't really get you quite far enough. So just to give you an example, and it's a sort of arbitrary example, but it is potentially a real-life one. If we consider us needing to do some kind of rolling upgrade across a set of nodes in a Kubernetes cluster, and within that, we've got a stateful set deployed using Galera. So Galera itself goes through a consensus process to form a cluster. There's an election process in which a master is established, so they know which one is responsible for responding to client requests. This is only kind of half true because you can configure Galera in a multi-writer mode, but just bear with me for the sake of this example. So yeah, at this point, you've got your service running. There's a single master established, and client request comes in. Those get handled by the database service. Everything's fine. If we go ahead and trigger an upgrade, what's going to happen is that Kubernetes is going to take that node out of action, which is fine to a certain degree. So things like Galera, for example, are designed to handle node last. That's the whole point of it forming a cluster in the first place. So it's protected. But as part of that mechanism for protection, it now needs to go through a process where it has to re-elect a new master, and this is before it can start servicing any client requests. So that might take a few seconds. Usually it happens quite quickly, but it can take a few seconds. Your client application needs to be designed in such a way to handle that database connection going away. So you're going to implement things like connection pooling. Best case scenario, everything comes back up, it re-elects a new master, and then it's back in service. Worst case scenario, you've got a problem with the cluster, it's losing transactions, you've kind of got to roll up your sleeves and troubleshoot it at that point. But let's just say everything works according to plan. We've got a new master established. At that point, this service is once again functioning and returning, doing something meaningful with its clients. The upgrade of the first node finishes and a new master is brought online. And the problem is that master, when it was shut down disgracefully, and it's come back up expecting it to be the master again. So before it can rejoin the cluster, it's got to go through a whole election process again. That's all triggered. Eventually the cluster settles down, we have a new master, and then what happens next? That one's taken down. So we're kind of back to square one. So it's going to ripple through every single instance of service that sits behind that Galera cluster, and it's going to be obviously quite problematic in the meantime. And that's just specific to Galera. So other applications, Galera, Galera is quite resilient with applications and much more sensitive when it comes to this sort of thing. Fortunately, before I move on to how Kubernetes Operators fix that, I don't think any slide will be complete without at least either some dank memes, which I don't have because I'm over 40 years old, or at least a quote from Kelsey Hightower, who is the font of all knowledge when it comes to anything related to Kubernetes. And this is a fairly recent tweet of his, coming back from March, where he recommends that people exercise extreme caution when it comes to running stateful workloads. I like a challenge, but at the end of the day, a lot of this stuff is about a lot of what Kubernetes provides, and the ideal of Kubernetes is that it eliminates all this toil and all this manually having to finagle a database when there's some kind of a problem. So the emerging solution to this problem is the operator pattern. This is actually been around for a while, and it's kind of a hot topic right now. And this gives us a way of orchestrating these stateful applications. One of the best things about Kubernetes is the fact that it's modular. You can just plug in extra bits and expose different operational aspects via a Kubernetes API, and then just use the tools that you're familiar with. And basically, operators give you exactly that. So you get this application-specific controller. It extends the Kubernetes API using custom resource definitions, and it lets you encode all that domain-specific operational knowledge within code that's in the operator itself. which gives you a nice, neat API that you can just ping for a given service like Kafka or like Galera, for example, and that will then take care of doing something like an upgrade. And it, ideally, it should automate things like failure recovery scenarios. So it's got the smarts in there to know how to recover a failed cluster. And then, we can do, because it's all then presented as an API, we can do cool stuff with scheduling and everything else. So operators themselves, when you install them, you'll get the operator, and that's the code that manages the lifecycle of that particular thing. You'll get a bunch of CRDs, and then you can instantiate resources using those CRDs, populate them with some data, and away you go. The point I wanted to make here really is that each operator is purpose-built for the application. So you get an operator for Cassandra, an operator for Kafka, an operator for whatever else, and they all function a bit differently. The way in which they approach things is different, and there's no commonality across the operators. So operators are a great solution. They're very much the right way of doing things. They're very much the right way of encoding that domain-specific knowledge. So now that I've sold you on operators, how do you go about actually developing one? So as of right now, there's kind of two main ways of developing operators. The first one is the operator framework. So this is the one that actually grew out of CoreOS. CoreOS being the people that actually coined the term Kubernetes Operators in the first place, so they definitely know what they're doing. It's obviously now maintained by Red Hat and IBM. Now, all one thing, the deal has been completed and everything signed and sealed today. And you've got a few options there for developing operators. You can use Ansible, you can write them using Helm charts, or ideally you want to use Go. If you want to do anything beyond like some fairly basic actions, then you're going to have to roll up your sleeves and start writing stuff in Go. Alternatively, there's KuBuilder. That's actually a sub-project of the Kubernetes API machinery sig. This is SDK purely in Go. You're going to have to write quite a lot of code to actually accomplish anything. Not that I'm saying don't write code, because writing code is fun, and certainly developing an operator is fun. It's a good thing to go through, but it's a lot of work, to say the least. And not only do you require quite a lot of Go expertise, you also need an awful lot of knowledge about the depths of Kubernetes internals. And it might require thousands of lines of code. I can give you a concrete example for that. There's a friend of mine that works for a prominent NoSQL vendor. He's one of the smartest people I've ever worked with, and he's sort of mostly responsible for writing their operator, which is one of the best ones that I've seen. He tells me that it's closed source, unfortunately. It's 40,000 lines of code that took a year to write, so it's pretty big. And then it's making sure that you actually catch all the edge cases. So it's making sure that the worst thing that you want is for an operator to not do the right thing in production. So you've got this thing that's orchestrating this complicated set of actions with a stateful application. And the last thing that you want is for it to do something wrong or for it to miss something. And then again, you've got operators that are having to sort of dig in and troubleshoot and then fight the operator itself and actually, fix whatever the problem is. So they're complex, a lot of domain-specific knowledge, and there's quite a lot of edge cases that you need to try and capture. Fortunately, there's Kudo, which obviously is what I'm here to talk to you about today. Hence the T-shirt, hence the stickers, hence the presentation that you're all enjoying, I'm sure. And so speaking on Mesosphere's behalf, when we started to look at the operator landscape, it was actually fairly familiar. So Mesosphere have got another project or another product called DCOS. DCOS has been around for quite a while, and DCOS itself was designed to run stateful applications. So it's quite fundamentally, it's sort of different background and mindset from Kubernetes. There's a lot of crossover, but they're actually quite fundamentally different. But it was designed to run stateful applications, and there's a thing called the DCOS Commons SDK. So if you want to run your application on DCOS, use the DCOS Commons SDK, and it kind of gives you this framework for making sure that your stateful application runs on DCOS and runs in the way that it's supposed to run. So we sort of saw the same thing happening within the kind of operators community, or the Kubernetes community, if you like. A lot of people, there's a lot of duplication of code, a lot of duplication of effort, and we thought, maybe it's a better idea if we kind of standardise on one way of doing things. So we took those lessons that we learned, and that's where the Kudo project kind of came from. So Kudo itself, it's an acronym for Kubernetes Universal Proprietary Operator, and it differs quite fundamentally from the other examples that I've given you, sort of, and I'll come on to why that's not entirely true in a minute. It's a universal operator, so you have just one operator, which is deployed as a controller, and Kudo kind of takes care of doing the rest. Instead, you write Kudo operators, and then Kudo itself is the thing that translates that into a Kubernetes operator on your behalf for different applications. The good news, sort of good news, I wince as I'm saying this, is that it's all configured right now using YAML. Obviously, we all love writing YAML. There is a plan in future to replace YAML with something else, but right now it is YAML. But it is at least much more straightforward. You're kind of encoding this commonality and this reuse between lifecycle operations, and then you're encoding that just in lines of YAML. And it's got this concept of plans. I'll talk a bit more about those in an upcoming slide. It's a completely open source project, so it's licensed as Apache 2. It's an entirely open development model. If you're used to doing any development in any of the Kubernetes projects, we've adopted exactly the same process. And yeah, eventually it's going to be so feature complete that you can just say things like Kudo make me a sandwich, and maybe I'll get a sandwich. If we compare it to the other ones, like I say, it's a universal operator. Oh yeah, so under the hood, Kudo's actually using KubeBuilder, so you can think of it as a way of simplifying KubeBuilder development. That's one way of looking at it. You write operators themselves, you write Kudo operators themselves, which is templated YAML manifests, and instead it gives you this high-level set of CRDs that represent different bits of your workloads. It's kind of focused more on operators or SREs being a bit more productive, and giving you those primitives for a high level of coordination of software life cycles. Like I was saying before, there's a lot of emphasis here on day 2 operations, where there's a degree of expectation around service maturity and how you run these applications on your Kubernetes platform. The other thing I should mention at this point is that I mentioned it's entirely open source. It's just vanilla Kubernetes. Like I say, it's actually translating the representation of a Kudo operator into an operator on your behalf using KubeBuilder. You just use kube control. It's all standard stuff. This will become a bit more apparent when I do a demo. The point being really that it's much easier to learn. You don't have to learn any new DSLs. There's no proprietary APIs. There's no additional requirements. There's no external data stores. It's really easy to pick up and use. So before I move on to a demo, I am going to talk about a few sort of high-level Kudo concepts, because that bit of context is kind of useful. So you've got your application, and at top level you've got a Kubernetes, a Kudo operator, and this is a high-level description of a deployable service. A deployable service being anything that you want to run in your cluster. It doesn't have to be a complicated stateful application. It can be something actually quite simple. And yeah, it provides a set of custom resources and types, and those are then represented, or an operator is represented as a CRD object. Next up, there's the operator version, and that's actually the implementation of an operator. This is kind of the meat on the Kudo operator bones, if you like. So this is where you have all the information, or all the information that you need to feed to Kudo for it to be an operator on behalf of your application. It represents a specific version of a deployable application, and it contains all the parameters, the plans, objects, so on and so forth. And then we have an instance. So this is the actual, this is how you tell, or rather this is how Kudo creates an operator that tells Kubernetes on your behalf to actually instantiate your application, which is then tied to the operator version. So once created, renders all those parameters that you have in those templates, such as pods and stateful sets and all the rest of it. The point that I want to make here as well, that's quite a cool feature, is that you can have multiple instances of an operator version of your cluster, and you can have multiple operator versions as well. So this is really useful because sometimes software developers and applications, distributed stateful applications, they kind of change that set of operational considerations between major versions. So how you upgrade, or even minor versions, to be honest. So how you upgrade, the version of Gradle today from one version to the next, or how you do a backup might differ from. That's actually a poor example because it's always been the same with Galera. But I think you get the point. And the idea being that you can have multiple operator versions, and you can deploy multiple instances from multiple operator versions. You can mix these across your cluster. I mentioned before about plans. So plans you can kind of think of as a structured runbook that is then executed by software on your behalf. And it allows you to break down tasks into phases and steps. This is what you define for a given operational task that you want to expose by the Kubernetes API. Typically you define several plans, so deployments, backup, restore, or upgrades. And there's also a strategy you can associate with steps and phases actually. You can either do them in serial or parallel. So you could be quite aggressive and run multiple steps of an installation in parallel, for example. But it could be that taking a backup is something you want to do serially and make sure that some storage is in place first of all before you try and take a snapshot. Finally, there's plan execution, and this is the custom resource that stores all the inputs and status of an executable plan. Each execution of a plan gets its own CRD, and Kudo's got there's a handy plugin for the kube control command that gives you this kind of nice output of exactly what's happening and where. So yeah, so again, I mentioned before that it's just another Kubernetes. You don't have to use a CLI extension. You can just use kube control, but Kudo kind of gives you, using the plugin kind of gives you a bunch of convenient extra subcommands that you can use. So at this point, in case my demo didn't work and doesn't work, I've got some screenshots that show a bunch of YAML, which isn't particularly interesting. I'm sure none of you actually want to look at. So what I'll do is I will flip over to the demo. That's one of my favourite GIFs and one of my favourite films. I'm sure you all recognise it. Just give me a second because I need to flip this over for the stream. Let's switch to okay. Let's truncate at the bottom. Let me just fix this real quick. Is that big enough? Can everyone read that? Bigger, you say? Mass? That look okay? Cool. Okay. So let's run through what a Kudo operator looks like, and then what I'll do is I'll deploy, again, time permitting, I'll deploy. How am I doing for time? Is anyone keeping track? Am I okay for time? Okay, cool. Right. So what we'll do is we'll look at an operator in Kudo first of all, how it's comprised, and then what I'll do is I'll do a Kafka deployment. That has a dependence on Zookeeper, so I'll deploy Zookeeper as well. And then I'll look at a quick look at the MySQL example. So you've got a bunch of different ways in which you can actually install operators using Kudo. Right now, you can install from the local file system either as a tarball or just as like a set of folders. You can deploy. There is now a Kudo operators repository. You can also deploy from a URL, so you can just pass it a URL. What I've got here is a checkout of the operators repository on my laptop, just for the sake of expediency. So if we take a quick look at so this is like the top level definition for the Zookeeper operator. There's a bunch of just a standard metadata definitions that you'd expect at the top. These examples that we have right now are really basic, but there's people actively working on fleshing these out to be a bit more fully functional. And again, this is something that if you're interested in this sort of thing, you can certainly help out with. So I mentioned before about plans. So we've got here a set of plans that we've defined. This one's got just 2 plans. So there's a deployment plan and a validation plan. I mentioned before about strategies. So there's a serial strategy for this deploy plan. There's a single phase called, not very imaginative of the title, but it's called Zookeeper. The strategy for that is parallel. It doesn't actually matter in this case because there's only actually one plan. And that's got 2 tasks, an infra and app. So if we take a quick look at the top at tasks, we can see that these 2 tasks here list a set of resources, and these resources are just our YAML files with our templates. So if we take a quick look at those, for example, look at the templates. So if we look at that stateful set, I mentioned before about it just being templated YAML. It's templated using Go templates or Sprig if you've come across that before. So it's a standard stateful set definition with a few templated sections that get interpolated for us when we actually go ahead and instantiate this on our cluster. Parameters you can override. You can ship with a parameters file, so it looks at both parameters and includes those. Or you can actually pass those in on the command line when you actually create something. So what I've got here is I've got two things, one of which you won't be able to see. I've got a separate application that I'm going to, again, to speed things up, and because typing in front of an audience is difficult at the best of times, I've got a bunch of commands I'll just copy and paste. So what I've got here is it's a Kubernetes cluster that's deployed on my laptop. It's just deployed using kind. There's not really anything running on it. Yeah, it's good enough for the sake of this demo. So if I do, right now there's no CRDs. I haven't actually deployed Kudo, so that's the first thing that I'll do. If I try and do, if I go ahead and deploy that. So now, if I do kubectl get CRDs, so that's deployed and running on my cluster. I can now do things like kubectl get instances. So as I mentioned before, it's all just vanilla. There's nothing new to learn really. So kubectl get instances, get operators. I've not actually installed any operators yet, so this is kind of what you'd expect. There's no resources found. So if I go ahead and install Zookeeper. So there's a command to do it. I mentioned before about there's a Kudo subcommand. That's what that is. So I'm going to create an instance. I'm going to give that instance a name, Zookeeper. I'm telling Kudo to install it from my local file system. And if I don't pass the auto approve flag, it will ask me by default if I want to create an instance of Zookeeper. So I can say yes. And then in the background, it should be going away. It's on those pods. This is going to be. So I've just realised that I'm actually tethered to somebody's phone. So because nothing here is cached whatsoever, this will take a while because it's going to download the Zookeeper image to deploy on my cluster. So the chances are this won't actually complete. So that might cut my demo a little bit short. Let's see. Give it a minute. Give it a second or so while I drink my drink of water. Yeah, that's going to take a while. So that means I can't deploy Kafka, because Kafka has a dependency on Zookeeper. Eventually, though, you'll have to take my word for it that would complete, and we would have a 3-node Zookeeper cluster if we gave it enough time to actually pull down the image. While it does its thing, let's take a quick look at the MySQL example. Because again, this is a bit more. This is definitely a proof of concept, and it doesn't actually deploy MySQL in any kind of clustered fashion. It just deploys a single instance of MySQL, so it's less than ideal. The reason why I wanted to show it is because it does actually have multiple plans that have been defined. So not only have you got a deploy plan, you've also got a backup and restore plan. So this gives us some Kubernetes API primitives that we can then use to do things like take a backup or perform a restore. And again, it's exactly the same configuration and structure. So we have a set of plans that are defined for that operator that we want Kudo to create on our behalf. There is a strategy associated with the deployment phase, and then there's a set of steps that sit within that. And then if we look at the top at the tasks, we can see that for a given task, there's a YAML file or a number of YAML files that can be associated. So again, if we take a look at so backup PV just creates the persistent volume claim, and then there's the actual bit that takes a backup. Again, this is all fairly straightforward. It's just really meant as a proof of concept to demonstrate the sort of things that you can do with Kudo. Let's see how my Zookeeper deployment is doing. Oh, got one running. Okay, so hopefully in a second I should have a Zookeeper cluster. Okay, that's not very exciting. So what I'll do is I will deploy MySQL as well. So if I install the operator first of all. Bear with me a second. So that's going to go ahead. If I now look and do run that command, I can see there's now 2 operators that have been defined and deployed in my cluster. I can see that there are 2 instances, which is what we'd expect. I've got 2 operator versions, 1 per operator, and then you can do stuff like you can actually see what it is that Kudo has created on our behalf by doing. Sorry, fat fingers. So you can see there what's actually been the CIDs that have been created on our behalf and populated with various values. Okay, so I've got a zookeeper cluster. I've also got a MySQL instance that's being created. So I mentioned before about the fact that there is this Kudo CLI plugin for kube control, and you can do things like we can do something like, if I do this. So that there gives me a pretty neat output that breaks down exactly what it is that Kudo is managing on my behalf in terms of the plans that are defined for my MySQL operator. So as we saw before in those YAML files, in that top level operator.yaml, there's a deploy phase, there's a backup phase, and there is restore phase. And then for any given piece of those, it kind of updates. It updates those different sections based on what it's up to. So again, if we waited long enough, that should eventually come to life. Okay, so it looks like it's deployed MySQL. There's now a deploy job, which is this init step here. That's now running. With a bit of luck, after a second that should complete. And then I can just very quickly show you what it takes to do a backup or a restore using Kudo. So clearly one of the bugs that we need to fix pretty soon is the fact that each time I run that command, it's displaying these in a different order, which is probably very confusing. It's confusing me, I'm sure it's confusing yourselves. Okay, cool. So that's all now marked as complete. So that deploy phase has gone ahead, done the deploy, and done the init, and done the cleanup step. So now, if I do so that's running the MySQL CLI in my pod and just tell me which tables exist in the Kudo database. So I can go ahead and populate that with some data. Yeah, just any old data. And then if I query that, there we are. I've got 3 rows worth of data in my database. What that means is I can do, I mentioned before about a backup step. So we can go ahead and invoke that. This is a little bit rough around the edges, but it does do the trick. Just to show you what the actual backup step looks like. So this is something that is going to be updated. I'll come on to what the future of Kudo actually is, but this is something that I fixed quite soon. So right now, things like CRDs like backups and restored, those are instantiated when you actually install the operator via Kudo. It would be much nicer if these were dynamic or extensible in some ways, which they're not, unfortunately. Which means that it's fairly static, but it does mean that I can very easily take a backup of my MySQL database just by running one command. So if I go ahead and apply that, it would help if I pointed to a file that existed. So if I look at the output of plan status, we can see that actually in the time it took me to run that command, it already managed to run through the backup plan, so we can see that those are now complete. So So now that I've got a backup, if I go ahead and let's just delete some data. And if I now do that, then there's nothing in my database. And so the same in reverse. I can run that. There's a restore definition. If I can show you that real quick. Oh, I've done a restore. If I take a quick look at that. Again, similar sort of thing. Just basically tells Kubernetes to populate that CRD for the backup plan, for the restore plan rather, and I'll go ahead and run that. So we can see now that the restore plan is also completed, and if let's just take another look at the database, we should see that my data is back. So it's a fairly arbitrary example, but it kind of hopefully demonstrates how relatively easy it is to encapsulate that operational set of tasks and run it as a Kubernetes operator using Kudo. So back to my presentation. Bear me 1 second, I've got to swap the screen over again. So I found the right browser tab. Should be that one. Yeah, back to my favourite GIF. Does everyone know that this GIF has got a website, by the way? If you point your browser to .holdings, you get that GIF. I think it's very cool. I'm not actually sure if this joke. I'm not sure if this joke translates, but hopefully your minds are all either blown or you're all sat here smelling pizza, wishing I would just get on with it. But hopefully that demo gives you an idea of exactly what you can accomplish today using Kudo. As far as the future of Kudo is concerned and the sort of upcoming features, I mentioned before about dynamic CRDs. It would be nice if you could define or update existing CRDs during runtime operation. This would allow for much more sophisticated, like operational orchestration. Would mean that we can represent operations as first-class Kubernetes objects. Right now, the set of CRDs that you get to play with is quite limited, so that's coming up pretty soon. Framework extensions will also be really awesome. So there's already a set of operators for Kudo that have been developed that are being fleshed out. It would be nice if you, as an operator, didn't have to fork that repository and maintain your own fork, and then that's a whole mess. It would be nice if you could just sort of inherit those and then add on a few features yourselves and just extend those in any way that you see fit. This also leads to a few other features that have been developed. So one of the original authors of Kudo is one of the people behind Helm. So one of the features that's in process is the ability to extend Helm charts, and then eventually to be able to actually import Helm charts all together and have Kudo create an operator managing the entire application lifecycle on your behalf from a set of Helm charts, which is really cool. And I mentioned before, YAML. We all hate YAML. It's a necessary evil at this point. It's like a lowest common denominator. It does make things a lot simpler, but it's not ideal for the task in a lot of cases that people end up using it. And in our case, again, that's also sort of true. I also mentioned before how under the hood Kudo makes use of a couple of existing community projects, KuBuilder and Kustomize being the other one. So Kustomize is actually a CLI tool, and the way Kudo builds its representation of what it wants to present to KuBuilder doesn't kind of mesh very well with using Kustomize. That whole process is a little bit fragile. It means you can't do very complicated things, and yeah, it's not the greatest configuration. So we're looking at switching to Q instead. I don't know if anyone else here has heard of Q. It's a fairly new thing. It's come out of Google. It's heavily influenced by the Borg configuration language. It's a superset of JSON. It's kind of DSL-esque, but it does give you things like a set of data constraints, typing, removes a lot of the repetition, and introduces a lot of safeguards that you can't really get with YAML because YAML was never really developed for that sort of thing. So one of the points I wanted to make is that now is actually a really great time to get involved with Kudo itself. It's in the proposal stage for being in the CNCF sandbox, so it will get the CNCF stamp of approval fairly soon, I hope. So if you want to come along, there's lots to do. If you want to just stretch your legs as far as code contributions are concerned, there's lots of low-hanging fruit and easy issues to get started with. Writing operators is super easy, so you can help us to flesh out a few of those. Yeah, we'd really like to build a community around this thing. And yeah, so my last slide is just a bunch of links. Feel free to come up here. I've got a bunch of stickers. If nothing else, I think the branding is really cool. So feel free to grab a sticker. There's a Kudo website, and then there's a couple of GitHub repos, and there's also the Kudo Slack on the or the Kudo channel on the Kubernetes Slack rather. And that's basically it. Have I got any questions? I appreciate it. I'm already over time, and I've gone really quite quick, so hopefully it made sense to everyone. Quick, simple questions. Yes or no answers, ideally. Okay, yep. Easy. Thank you very much.
Hey, hi everyone, I'm Ramiro, nice meeting you all. I'm one of the co-founders, co-creators of Cheto, along with Pablo, who was there at some point, over there. We have some t-shirts, so you'll find it. Before working at Cheto, I used to be an architect at Atlassian Enterprise. Before that, I worked for a few years on Azure as an engineer over there. And that's my Twitter. I'm gonna connect, feedback, just troll around, all that. So today I'm gonna talk about what we've been calling cloud native development. I'll talk a little bit about the current state of application development, why it is so hard to build cloud native apps, how can we all make it easier on everybody, and then I'll give you a demo of some of the tools that we've been building around this interesting scenario. Okay. All right. So you've seen this before. Maybe you've heard of this startup, Docker. There's another thing called Kubernetes. The last few years, these two things came into the mainstream and really changed how we build, think, deploy, run applications. Through these two technologies, they really solved a lot of the biggest issues we've had in the past around scaling, around upgrades, keeping things running, all of those things. However, it wasn't free. They made it easier for us to run things at a very high scale, but it did make the developer experience a lot harder than before. If you remember how it used to be, go back 10, 15 years ago, when Ruby on Rails was a big thing. And this is how an application looked like. Like your browser, it was a router, a controller, a model, a view, a database. You could run everything locally, then came Heroku, VMs. It was very simple to use. It was very easy to iterate. Everything could run locally, and there were not a lot of issues. Things maybe didn't scale as much as today, but it was simpler. And then this happened. Microservices came, and this is how our applications look like now. We have a bunch of services. They might be on the same location. They might be across the planets. They might be all might be owned by you. You might be calling third-party APIs. Local stuff all over the place. So things became a lot more complex. And however, our tools haven't really evolved with it, and that's what's making cloud native applications particularly hard to build. For us, and it's kind of Pablo and I have been working on this for a very long time now. For us, one of the biggest issues, problems we have when building applications that are meant to run on Kubernetes, Docker, is how much friction there is on your inner dev view. It looks like when you're writing code, you're saving, you want to test your code. It's how quickly can you get a line of code across to test end to end. Before, this is kind of how it looked like. You wrote your code, you build it, you test it, and that's it. And you kind of keep going around, do this 1,000 times per day. Eventually, you have a feature and you ship it. With containers and Kubernetes, it became something like this, where you're going to have to write your code, sync it across whoever's doing the build, whether it's a Docker daemon, it's a remote build system, whatever, tag it, push it to a registry, pull it somewhere, deploy the new version of your application, then test it, then see if this line of code really fixed what you thought it fixed, and then you go over again. And this could be optimized, this could be fast, but still, if you're doing this 15, 20, 50 times per day, it becomes a very slow cycle, and it starts to slow you down, you lose context of things. When you're waiting for your Docker build, you're gonna go check your email, go on Slack, and it reduces all of our productivity. And we're not the only ones that have been seeing this problem, talking about this. This is a problem that the entire Kubernetes community is really, really aware of. There's a lot of solutions in the market for this. I recommend you check out this Elle from Garden.io. It's a startup based in Berlin. They're also building Kubernetes DevTools. She gave a talk on the state of Kubernetes tooling, and on this presentation, she talks about all the different tools there are, and she makes a really good classification on how they're fixing, whether they're trying to solve the deployment problem, the build problem, the inner loop, coding. Like, there's a lot of teams, projects, companies in the market trying to attack this problem because we all agree that not being as efficient as we have, having to fight all this infrastructure just to be able to deploy code, it's a big deal. And why is hard? Well, the first thing is, once you move to this cloud-native world, your local environment is no longer that replicable. Because one thing is your local machine with all your services running. Another is a 25-node cluster distributed across 3 regions with SSL, load balancers, and all these other hubs. You still have this very different environments between where you're coding and where your application is supposed to be running at. Second, and this happens a lot to us, I'm seeing it happen a lot, is you start having to maintain all these different manifests. You have your Docker file and your Docker compose for local. You may have a different script for your CI/CD, and then you have your manifests, customized, Helm charts, all these different things that you have to keep in sync. Whenever you make a change, whenever you want to add an environment variable on your local code, then you have to go and chase to see where else it's defining. Again, it's friction. It's more things you have to worry about other than just your code and your applications. Then we have environment exposure. It's something I've seen happen a lot before, and now with Kubernetes even worse, because you have your dev environment locally. And as your applications mature, most likely you're not going to be able to run your entire application locally. So what's going to happen? You're going to have your local dev environment, then there's going to be a shared integration environment somewhere. You're going to be sharing with your team or multiple teams. This one most likely will be broken most of the time. Then you're going to have your staging environment, hopefully, and then production. And each of these environments needs to be maintained, needs to be kept up running. All of them are slightly different because of versions, networks, permissions, whatever. So it becomes like, you see what I'm talking about. It becomes this increasingly complex thing that gets harder and harder to maintain and harder to focus on just building features. And as I mentioned before, not being able to run your application locally becomes a big deal. It's a problem. It's one of the things that I've seen that really slows us the most. So you have to start making a lot of assumptions, doing a lot of mocking or just guessing things locally, and then you rely on CI or even on production just to be able to truly verify end-to-end the features that you are building on. And all of this adds up to it. It becomes really hard. It becomes really frustrating. I've seen teams where they give up on this and they decide to just build things locally, just focus on one service, and then eventually they just trust CI will catch it, or they'll have candidates, and candidates will catch it, or in some cases, production will fix it whenever we gotta pay your duty or whatever. It happens because a lot of these people just really get frustrated about the whole thing. Is you have to build all this infrastructure for something that used to be as simple as, hey, there's some PHP code, just rsync it to the server, and it will just work. Again, I mean, we are solving a lot of things with Kubernetes and Docker, don't get me wrong, but there is the developer experience of it is where we believe is the weakest point. And that's why we've been working on this. And that's how, after working for a few years on this, is how we got to this thing that we are now calling cloud native development, and how this makes it easier for all of us. And this is kind of what I want to talk and kind of evangelize and kind of convince you to move to this modern way of development. Cloud native development is the idea that you should develop your applications in the same environment where they're going to be run. What does this mean? It means that you should be using the same configurations that you have on production, on staging, on dev, on integration. Kubernetes is very API-centric. It's a lot more API-centric, a lot more manifest-centric than Cloud and EC2 and DigitalOcean, than Terraform, all these other things. So it is easier than before. It takes a lot of discipline. You should be moving in this direction where you are testing with the exact same things. If you're going to be using EC2 in production, you should have it in dev. If you're going to be using Knative for builds, you should be using them all over the place, operators, all these things. Number 2 is stop mocking your dependencies and just use the real ones. This is something that's, I know it's a bit of a controversial topic, but I've spent so much time catching up on API contracts and mocks and local things that gave me this false sense of assurance. And then you go to production and, oh yeah, the API changed. I no longer get this error code, I get a different error code. So stop doing that. Instead, make the investment and start using the dependencies from day one. If you're going to be using, I don't know, RDS for database, use it from day one, because you're going to start seeing as you develop all these different things that you hit while building software that you never see in your tests. You never see DB slowdowns in your tests, or barely see them. You never see services offline or fluttering as you see when you're developing. So by using these dependencies from day one, you start to learn about them and see how they behave statistically. And second, you start building your applications in ways where they're actually consuming them natively, when you understand all these APIs, all the way they behave, and instead of just saying, all right, I'm going to call the database this way. Just call a SQL, connect, everything works all the time. No, you start seeing that, RDS sometimes refuses a call. Sometimes you have to reconnect. Sometimes your query takes 10 seconds. Sometimes it takes 30 because you're in a shared environment. Seeing all these things from day one, from development, really, really helps to adapt your code, to make it more robust. And that's something that's super important as you think of building distributed applications. And this is for me, for us, kind of like the key point here is it's very important as you adopt this idea of cloud native development to truly invest on an agile development workflow. And I'm talking agile in terms of Scrum and waterfall and sprints. No, I'm talking in terms of automating as much as you can so you're writing code and everything that just happens for you. Please, if you're moving to Kubernetes, if you're using containers, if you want to build things in a cloud native way, don't stop for building Docker images and pushing them. There's a ton of tools out there, Scaffold, Draft, Octeto, Garden, Tilt, to automate all of this for you. Remember that every time you have to switch context from writing your code to trying to figure out which tag to use, which register you have to push this from, what's the password for the Docker Hub account and staging, all those things is just time that you're going to lose from your flow. You're going to have to kind of go back and spend the next 15, 20 minutes kind of warming up back to where you were. So please really automate. That for me is kind of like the most important one. If you get one thing out of this talk, is automate as much as you can from your daily flow, because remember that even if it takes a few seconds, you're going to do this 100 times per day. How often do you save a file? How often do you have to rebuild your containers? If it takes 1 second and you do it 200 times per day, you're talking about hours and hours of time just looking at Docker build logs and trying to figure out, okay, come on, next. So do that. And the other, and this is also something that becomes, as you start using it, you start to notice how much more efficient you are. Is try to reuse your artifacts as much as possible. One of the problems I've always had with CI/CD is that you have a way of building and running things on CI, and a different one when you're doing locally. And then you always struggle with oh, how do I build my environments for integration tests? How do I deploy this locally to get the same endpoint that I get in staging? If you move to a way, and this kind of ties back to the first point of using the same environments everywhere, if you keep your same manifest, if you keep deploying the same way, using the same containers, the same build scripts, this becomes easier and easier. In particular, if you have containers and you're doing multi-stage builds, try to build those in a way that you can reuse those stages, whether it's across services or even just as where you run your unit tests, where you're building your dev environments. If you have a Docker image where you're building Go with all dependencies, then you copy the binary, try to reuse this first phase as your dev environment, as your sandbox to run your unit tests. It's a really good way to save time, to reuse, and to catch all these annoying issues where you're missing one dependency, you have the wrong version of pip, and everything is kind of acting slightly different. So take care of that. And finally, leverage Kubernetes on demand. The on-demand compute Kubernetes is amazing. You can launch a container in seconds. VMs were never as fast. No matter how much you tune up a VM on AWS, you're never going to be able to rival how quickly Kubernetes deploys containers. Use this as your favor. Now that we have this compute, just use it for everything. Every time you want to run something, just spin up a container. If you're going to write some code, spin up a container, write your code there, run your unit test there. You don't have to spend time cleaning up environments anymore. Spin up your environment, run your test, kill it, move forward, do it again in the next 5 minutes. It takes seconds to spin up a container. Just stop dealing with local things, stop dealing with installing dependencies, trying to figure out why your environment, where do I have to remove files to make my environment less unstable. Just ignore all of that. Launch, get used to the compute. Kubernetes is really good at launching compute, at putting as many containers in one VM as possible, and making us go fast. So that is something that, as you evolve your dev practices, take advantage of this. It's something that is, it's not that obvious, but using containers as dev environments, using Kubernetes as this provider of infinite compute, it's a really useful thing when you're building, not only for running your applications, but when you're building them as well. So as we were going through this journey, as we were building all these cloud applications, we kind of kept refining this idea of cloud native development. We did run into some challenges, especially as we talked to some of our friends who work on larger teams, on more traditional organizations. The idea of giving developers access to clusters where they can just get all this compute is scary for a lot of people. There's a lot of reasons for this, all of them valid. There's something around like how much work do I need to do, how much permissions do I need to give everybody, how do I deal when somebody breaks a cluster, fair use, all these things. So there are challenges. For me, one of the biggest one is that you need to give everybody self-service access to this. Having people use Kubernetes and all these clusters as in production means you to give them access to the entire thing, to be able to call the Kubernetes APIs, to be able to run install chars, operators, all these things. And it has to be self-service. You don't want your team to be filing tickets every time they need to create a new namespace, every time they need to get an account on a new cluster. Because otherwise you're gonna have a million tickets waiting for you or for your IT team, and nothing's gonna happen. And people are gonna start trying to go back to rogue IT where they're spinning up their own clusters, running Minikube and VM somewhere, and it gets messy. Sharing clusters is another challenge. It's hard because Kubernetes is not multi-tenant on its own. You don't want to give everybody cluster admin access, and you don't want my workloads to be affecting your workloads. Like you want to find ways where I can't just spin up a million containers in my namespace and sharing with you, where you don't have access to compute. All of these are challenges. We need to make sure that as you implement these solutions, think of how to attack this. Good thing is Kubernetes itself is moving out in this direction. There's a lot of action on the multi-tenancy. Special interest group, I recommend that you join. At least join the call, they're super interesting. And a lot of people in the industry are talking about how do we make Kubernetes multi-tenant, how do we make it easier to share in a secure way. There are different approaches here. You can go the hard multi-tenant approach that the guys from Culture Spin are doing. There's a multi-tenancy group. There's a few others there. Or just soft tenancy. Apply limits, quotas, give people namespaces. The key here is that think of Kubernetes as this massive thing that you're going to share. It's not trivial. It's possible. Just you have to prepare yourself. As we run into this journey, as we're trying to build cloud native applications for our customers, internal tools, we ran into a lot of these challenges, and we decided not to wait for Kubernetes, for the broader community to kind of build what we needed, and we started building a lot of these tools ourselves. Today I want to talk a little bit about Octeto. It's a CLI tool that we built to help move your development to the cluster. Octeto is a CLI. It's open source, Apache 2.0. You can use to create namespaces, deploy applications, create dev environments on the cluster, and then work on it. I'll give you a demo of it, but the idea behind Octeto was stop building things locally, stop this long cycle of push, deploy, run, and just move everything to the cluster. We started using it ourselves just because we were tired of waiting for Docker to build our Go app, because it would take minutes every time, because the kubectl modules is gigantic. We built that, started using it ourselves. We found it that was useful, and then we decided to open source it earlier this year. Just to, first, some of our friends, then we kind of started getting some interest from other teams, companies, so now we're kind of like making a bigger push towards getting people to use it. So please check it out. And if you're interested, if you like it after the demo, I'm happy to talk and show you all the things. So for this demo, I'm going to show you how to develop a Rails. It's an app that has a Rails backend, a React front end, directly in Kubernetes. We'll go through the entire flow of how we develop in a cloud-native way. Hopefully you like it. And hopefully it works. It's a live demo, so you know. And so everything I'm going to demo today, if you download our tools, you can do it yourself. The repo is there on my GitHub account. I'll share the slides later. All the links are there. So Octeto, the CLI, works on any Kubernetes cluster. As long as you have access to one, the Octeto CLI will pick up the credentials, launch, deploy, all these things. If you don't have a cluster, we have cloudocteto.com. You can go there and get free compute. Just log in with your GitHub account. This it's a tool we built. It's an application you can install on top of your cluster that turns your cluster into a self-service developer cluster. It helps you to manage identities, credentials, quotas, all the things we mentioned here. Something we built first internally for us, and now we're trying to make it into more of a, and now it's a product that we are sharing with everybody. So take a look, cloudocteto.com. So anyway, what I'm going to show you is, going to log in, is this application. It's called the App Garage. It's an application, it's a website, it's a catalog of applications. I picked it up from a demo on how to do Rails React open source. There's nothing to it. It's very simple. So the first thing we're going to do is we're going to deploy it. You can see here, there's two manifests, a deployment and a service. So what I'm going to do, though, is I'm going to use the Octeto CLI to get my credentials from Cloud Octeto. So the first thing you have to do is you log in. When you log in, we'll connect your account on the website with your account locally. We'll exchange a token to do create namespaces and things like that. So at this point, if you go back to the website, I already created a namespace for this example, React Rails, and that's my GitHub user. And I already deployed an instance of Jaeger. Jaeger, for those of you who don't know, it's an open census implementation to collect analytics, tracing, and see how your application is talking to other applications. Very useful when you're building multi-service applications, or if your application is calling a lot of dependencies, databases, caches. Just gives you a nice view of how your application is behaving, and when it slows down, it becomes really useful. And then we'll use that in the demo, but I'm going to start simple. So the first thing you do is you log into Octeto, and then there's a command called Octeto namespace. Yeah. What this command does is it will talk to the Octeto API. It will exchange the token for a set of credentials. So at this point, in my current context, and you see it here, I have a set of Kubernetes credentials, namespace, everything ready for me as a developer to work on a cluster without having access to anything, without having admin, without having to file an IT ticket, any of these things. So anyway, at this point, it's just vanilla Kubernetes. So I'm going to just apply my manifest. This will launch the application. If you go to Octeto, you'll see that it shows up here. One thing that this application does is automatically creates an ingress for you. It's pre-configured with an SSL certificate, the right DNS endpoints, a DNS entry, all these things. The idea with this is to make it super easy for developers to just build their applications. Instead of having to use ngrok and get an account for a DNS, or expose the IP, and then every time it changes, you have to kind of scramble around. We just wanted to make it as easy for everybody as possible. So we go here. And at this point, it will load the application. Very simple application. It's all, you've seen this before. Also like fake data. It's back in a SQLite app. Very simple, just good for this kind of demos where we're going to get deep into infrastructure and not so much into the code. So with Octeto, at this point, the first thing you do is you go to your repo. You see here I have this is my code. And you create an Octeto YAML. Octeto is all driven by manifest, uses YAML, just like the rest of Kubernetes. And a YAML looks like this. It's very simple. You tell Octeto the name of the deployment where you're going to be developing against, which image you want to use as a base for your development. The idea here is you have an image with all your dependencies pre-installed, your code, credentials, anything you might need. Which command to run? In this case, I'm just going to run a bash because I want a terminal to this dev environment where I can just run commands myself. And a working directory. And with that, just run Octeto up. Now this takes a few seconds. What happens here is that Octeto is going to start a synchronizing service between you and your Kubernetes cluster. We're going to start syncing your code. At the same time, it's going to try to find your deployment you gave it the name for. and it's going to take the deployment, it's going to analyze it, and it's going to replace the container in that deployment for your dev container. And it's going to mount this synchronized, the service is writing these files to a volume, it's going to mount this volume in your deployment. What this gives you is a deployment in Kubernetes where your code is synchronized in real time. So you can just run commands directly on the cluster without having to build your Docker file, push them, all these things. So in this case, I have an application. It's a Rails app, so I'm going to start it. At this point, my app is running on a cluster, on a container with my dev dependencies, the same as in production. It's using a single balancer, it's consuming the same services, all the things. If I go back here, you'll see that now it's taking a bit longer. If you go back here, you'll see that it's actually building everything on the fly. I have a plugin for the React components to just write them every time I do a request, is to make it easy to test. So at this point, you have your application, dev mode, ready to work. So we're gonna work on a feature. Let's say that we wanna have this app. It's a app marketplace. We don't have a search function, so we're gonna add a search function. Typically, you write your code locally, again, test it locally, ship it, talk to the team building the API, try to get an integration environment, all these things. With Octeto, we're gonna do it differently. We're gonna go to our code. I'm gonna cheat a little bit. I have a stash ready, cooking show style. Okay. So I have a stash here that's adding my React components. My search, first bar, the result, the list. I'm adding it here to my React on Rails to register my search component to add it to my index. This is using the React plugin for Rails, which is really useful if you're using Ruby. Super easy. Everything gives you an install hot available, so as soon as I apply those changes, they're going to be applied here. So I go back to my application. I reload the page. If you see on the console, you see it's building up the pages. And here now, you see there's a search bar. So I type something. What this is doing behind this is already calling my API service and retrieving the results in real time. So you see, we didn't have to build anything. We didn't have to push anything. We were already testing our code as is. This is not going to replace your CI/CD. You still have to, at some point, build your Docker file, push it, test it end to end. But instead of having to do it 15, 20 times until you get your code right where you want it to be, you can iterate a lot faster by just writing code and changing it quickly. And then, sure, go to your whatever release gates you might have at the end of it. So this is kind of the first thing, is giving you this dev environments. As you notice, I don't have Ruby or React or any of these things on my machine. It all came from a container, pre-installed, pre-configured for me. All I have to do is just git clone, Octeto up, everything's up and running. I have an endpoint, SSL, all the things. Now, this is kind of like the first part of Octeto, but the second part, and for me, is where it really gets a lot more interesting, is now that you're in Kubernetes and you're building things in Kubernetes, you can start to consume all these Kubernetes services directly as you develop. Again, not waiting until you are in an integration environment, not waiting until CI/CD to see how you plug in all these things together. So for this example, now I'm going to go to the backend, and we're going to use this Jaeger service that I deployed earlier to iterate and see how we can actually improve the performance of our application. In this case, just as before, I have a stash. In this case, it's a stash that is going to install, it's going to initialize a tracer. In this case, we're using a Jaeger. The host is called Jaeger agent because that's how the service is called in Kubernetes. If we go here, that service, you'll see we have all the things here. We have a Jaeger agent, a collector, the service itself, Zipkin, depending on what you need. For this example, I'm going to use the collector, so I'm going to just sending things through HTTP. So we just use the host name. This is the same as you would do in production. You don't have to fake it. You don't have to install a local Jaeger or get access to your network. The idea, again, is to keep everything as close as possible to production. In this case, we have a Jaeger agent configured. In a port, it's all internal traffic. And we're just going to use the name of our application as the service name to see the traces on our service. And then the other thing it added was, I just went with something simple. I'm just starting some spans for every operation on the application, on the index, on the search, when you see the specific application, just to give you an idea of how this would look like in real life. I'm not going to get too deep into how Jaeger and tracing works. I'm going to keep it simple. That it's a talk on its own, but it's something I really recommend you look into. Observability is something that's super important as you build distributed applications. So anyway, back to, you saw the code. In this case, I don't have Rails configured. The Rails component is not configured with auto loading, so you just stop it. Start it again. Go back to my page, and you see here, I added a log to just check to make sure that my Jaeger tracer was initialized. This is what you see here. Okay. It's here. So again, I just saved my file. Octado's taking care of all the synchronization behind the scenes. It makes it really simple for me. So I go back to my application. I'm going to reload it. I'm going to do a few things. Test, get in here, do it a few times. You kind of get the sense of it. So I go back here, and refresh this, and you see there's already a service here. You have the Jaeger query service itself, and App Garage. That's the name of the app. I'm just going to get all the possible operations from the last hour, find traces, and you see them here. So if we click in any of these traces, these are the live traces of my application. Every time I make a query, it'll hit here. So I can start, if you're doing something complex here, I can start writing code, checking Jaeger, seeing how long things are taking. Think that you might be trying to fix a bug on making your SQL queries more efficient. You can add all this tracing, start testing it. Get your standard scenario, start adding tests, improve your code, all in real life, all directly. And the cool thing is, because you're in a cluster, you can get a big cluster, and then you can start doing a lot of load testing, a lot of stress, things that you might not be able to do locally, because whether your machine is not realistically a realistic copy of your environment, or you can't really get the network right, all of these things. This is kind of the scenario we're pushing with Octado. It's the idea that if you're going to build your cloud-native applications, build them on the cluster the cloud-native way. All right, so that's it. As I mentioned before, Octado is an open source project. You can go to github.octado.com, octado/Octado. Please start it, fork it, collaborate, feedback, issues, anything. We'd really love to see what you think. Play with it. As I mentioned before, it's all open source. Cloud.octado.com is free. Please use it. Let us know what you think. We have a blog at medium.com/Octado, where we constantly blog about samples we build, kind of cool technical challenges we've encountered and how we solve them. So if you want to learn more and kind of like talk to us, that's the place to go. And finally, twitter.com/rveriesa, that's me. Please stay in touch. And again, try Octado and let us know what you think. We'd love to get your thoughts, your feedback, what you like, what you don't like, all these things. So thank you. Hope it was as useful, and I think now it's time to get some pizza. If anybody has any questions now or over there.
Hello, I just want to ask a question to you. It's about the synchronization, the first synchronization that is begins from the staff to the system. It's based on the file system, and it's based in the way in GitHub.
So the question is if the file system if the synchronization is based on the file system, or is it based on GitHub? It's based on the file system. We're using an open source project called SyncThing, and what this does is it detects every time a file changes locally or remotely. Like it actually works both ways. It will detect the event on the file, and it will synchronize the differentiation. Octado doesn't deal with GitHub. You could work in a way where you actually clone your repo directly in your remote environment, but this demo was not like that. It's just entirely file system. You can have your source control on GitHub, on GitLab, or even other systems. It's completely independent of how this works.